Hello, welcome back. Today we are going to solve a very important problem called valid anagram. So in this problem, two string S and T are given. We have to return true if T is an anagram of S, false otherwise. So first we need to understand what is a anagram. So anagram is basically a word which can be formed by rearranging the letters of a different word. Let us understand using an example. Suppose we have a string called it and another is t. Now if we simply count the number of characters within the string, we can see A appears one time, E appears one time, T appears one time. Similarly, if we check the occurrences of each character, we can find that each one occurs exactly one time. So if I now compare it and T, they both have exactly same number of characters with same number of occurrences. So it is an anagram of T or vice versa. So in this problem, we are given two such examples and we need to find whether the first string is an anagram of T. Otherwise, we are going to return false. How we can solve this problem? One, the very naive way to solve this problem is by shorting the characters. If you understand the first example, it could be pretty obvious that if we short both string, for example, we are going to short S and we are also going to short T, then we could land on exactly same strings and we have to just compare each other. If both strings are exactly same, that means S is an anagram of T. So let's do that for this example 1. So for this one, I have anagram. If we short, we have A, then again A, right? Then we have G, then we have M, then we have N. Did I miss anything? We have 3A, 1G, oh, I missed 1R, right? So how many characters are there? 4 and 3, 7. So there are 7 characters. If I now short this character, we will get all the A at the beginning. There are 3 A's. Then we have a G. Then we have N. Then we have, M, N. Then we have the R, right? Now if I compare S with T, both are exactly same. So we can conclude S is an anagram of T. Now if we could try with the example 2, right? So we have a rat. So for the rat, it will become A, R, T. And for the T string, if we short, it become A, C, R. Both are not the same string, so we are going to return false. Now, what is the time complexity of this solution? The length of both string, if n, they need to take n log n to short the string. Can we do better? Yes, we can optimize the solution by just understanding what we need to achieve. What we need to achieve is we need to find out for each character how many frequencies of each character is appearing, and exactly we need to count the same thing. So what we are trying to achieve is going to use a frequency counter. Now here is one observation from the constraint. It says S and T both are consist of lowercase English letters. So that means we have a 26 character bound, right? Now if we have an array, if that particular array can store only the frequency of each character, then we could use that array to compare both S and T to find out exact match or not. So for example, we are going to use the simple one. We have it and we have a T, right? For it, when we are going to process, initially all the character positions of this array are 0, right? Now each position is nothing but, we can think of A, B, C, Y, Z, right? These are the positions. Now so it, the first character is E. So the number of occurrences will be 1. Now when we process A, so there will be a E and we are going to put 1 there, right? We're going to put 1. Now for A, the number of occurrences will be 1. For T, there will be a T somewhere, right? This would be the frequency counter once we process S. Now once we start processing for the T, what we have to do, we have to decrement the counter. And once we process, all the array values will be exactly 0 if S is an anagram of T. So for T, again, we are going to now reduce. So that becomes 0. E, we are going to reduce. That becomes 0. For A, this becomes 0. Now, if we go through this array, all the array element will be 0. So S is an anagram of T. So we can understand with another example. So S is now rat, T is car. Now initially we'll have exactly the same array of 26 size. So let's just write these initially all are 0. So these are all zeros. So for the first character R, so hope there is somewhere R becomes 1. Then we are going to process A, so this become 1. And to process T, somewhere down the line it becomes 1. Now for this next string we are going to decrement. C, there is no value for C, so it becomes -1. For A, this becomes 0. R, for R, this becomes 0. Now if I go through this array, we can find out that all the values are not exactly 0. So S is not an anagram of T. So what would be the runtime of this process? That would be O of n, because we just process each string, all the characters in linear fashion. And this particular array, it's a constant memory because it's O of 26. O of 26, which is nothing but a constant memory. So this is our time and this is a space complexity. Hope you understand. So let's now code. So now first we are going to check whether S and T both are same length. That would be our initial check, right? If both are not equal, then we are going to return a false, because in that case we know S cannot be an anagram of T. Next we are going to allocate an array. We can just simply call this is a count. We are going to count of length 26. Now for each character from S, we are going to increment the count. Now how we can do that? We can put this way. So what it does mean, like for each character, we know that all are English lowercase, so we are going to divide, minus a means it will give me the exact index. For example, if C is A, then it would be A minus A, that becomes index 0. If A is like this character is B, then B minus A will be 1, the index 1. So this is how we are going to utilize our array count for storing the occurrences of the character. Now what we have to do, we have to increment the counter, right? Now again, once we process for S, we have to now process for T. Oops. For each character of T, what we have to check. Now here is one thing we can do. We can return or complete this algorithm before we process all the characters for T, in case if we find any negative values, right? So if the occurrences of any values is already negative for T, then we know that that value, that particular character is not like valid anagram. So we are going to check if C minus A, if this value itself is less than 0, then we are going to simply return false. Otherwise, we are going to reduce the count. And at the end, if there is no such falsy thing, that means we will have S, which is an anagram of T. So let's run this code. So if you like this solution, let me know. Just feel free to give me a like or comment on this section. Thanks for watching.